Good morning once again. We shall continue with the circle theorem, the part 2. As we started earlier, we said a chord is what will always form angles in the circle theorem. The chord that passes through the center of the circle. The chord. So when we are talking about chords over here, we have EF as a chord, CD as a chord, AB as a chord. When the chord passes through the center, it's given a special name called diameter. So the diameter is the longest chord in the circle. Moving forward, what we should know is this. As the chords are forming the angles, as I've said earlier, the chords are what will form the angles. And the chords will always divide the circle into two equal parts or two unequal parts. Let's check from here. Let's check this chord, AB. Have you seen that I divided the circle into this smaller half and all these parts? So all these parts will be called a major what? Segments. Chord divides circles into segments. Either major and minor, or two equal segments, which is semicircle, if the chord passes through the center. So over here, the chord that passes through the center is C or D, and it is called the diameter. Let's move on. As it is read, a chord will always divide a circle into two, namely two equal segments or two semicircle, or a major and a minor segment. The chord in forming angles will produce shapes in the circle. The two shapes that will produce are either a triangle or a quadrilateral. We should take note. The most common shape that we shall be seeing or be working with is the triangle. So from here, it can be seen as the chords. We have chord AB forming an angle at what? At the center, which is X, the center O, and has given us the shape of triangle. We have chord AB forming an angle at the circumference at C. We can also take it like this as the chord CB producing the angle A, or we can take it what? CA producing the angle what? AB. All depends on you. Chords are simply lines joining 2 points on the circumference of a circle. Have you seen that over here? These chords AD, DB, BC, and CA have what? Produce the shape what? Quadrilateral. This also produce what? The triangle. So these two shapes are what will be involved in the circle theorem. In the circle theorem. We shall be explaining them as we move along. The angle that will be formed within these two shapes can either be at the center or at the center of the circle or at the circumference. At the center of the circle or at the circumference. Let's see. There are only two areas that the angles can be formed within the circle. Either at the center, like this. The angle that we produce over here is at the center, like this, at the center, or at the circumference, like that, like that, like that, like that, at the circumference, at the circumference. Circumference simply means the edge of the circle, like that, at the circumference or at the center, at the circumference or at the center, at the circumference or at the center. That is within the circle. If it is formed outside of the circle, it will either be formed by a tangent meeting the circle at the point. Meeting the circle at the point. We shall talk about that. A perpendicular bisector of a chord by a line drawn from the center will always make an angle of 90 degrees with the chord. This results in the formation of isosceles triangle. When you say perpendicular bisector, we mean it simply makes an angle of 90 with another line. So example is what can be seen over here. We have the center O. Drawing a line, a perpendicular bisector, to bisect the chord AB will produce an angle of what? 90. And also we should take note, always the radius makes an angle of 90 degrees with the tangent. The radius always makes an angle of 90 degrees with the tangent. So moving forward and working out some basic calculations. The sum of the opposite angles. Okay, let's take like this. The total angle in a quadrilateral give us 360 degrees. The total angles in a cyclic quadrilateral give us 360 degrees. Opposite angles, we take it DC will give us 180 degrees. AB, their sum also give us what? 180 degrees. Opposite angles in a cyclic quadrilateral will give us 180 degrees. Total angle in a triangle will give us 180 degrees. Give us 180 degrees. Over here we can see a triangle that is isosceles. Since this one is the radius, this one is the radius, it means that the base angles are also the same, since their lengths are what? The same. Since their lengths are the same. Equal chords. This chord is equal to this chord. Chord AB is equal to DC. Equal chords will produce equal angles. Equal chords will produce equal angles. Equal chords will produce equal angle. So angle EBF is equal to angle GCH, meaning angle B is equal to what? Angle what? C. Angle B is equal to angle C. If a chord, how to identify, an easy way to identify the chord that form the angle is go to where the angle is and drag it down. Drag it down. Drag it down. You drag it from here, you come to the base. You drag it from here, you come to the base. So it's telling that this angle over here is formed by the chord AB. When you come over here, you drag it down, you drag it down. It's telling that it's formed by the chord AB. That's the base. So if a chord forms an angle at the center, then it will form half of that angle at the circumference. Let's take from this scenario. In a town, there are more people at the center of the town than at the nearby townships or suburbs. Example, when you go to Accra, there are more people living in central Accra than at the nearby towns. So always the bigger angle is the middle angle. Always the bigger angle. Also, I say a piano. In Timfin, time be also saying outside. In Timfin, so saying outside. This is telling us that half of this will be equal to this. Half of this will be equal to this. So twice of this will give us this. So example, if here is 30, here will be half of what? Of 30, which is 15. So if here is 15, here will be what? Twice, which is 30. And it always takes two shapes. Either it will be in this format, that's the arrow shape, or it can be in not this format. They are all the same. So 30, 15, 15, 30. We move on, then we come to which is the angle that are formed outside of the circle. That is a chord meeting a tangent. This one produces the alternate segment rule. The alternate segment rule states that the angle form at the other segment will be equal to the angle opposite that segment. So see the trick. The chord BC has divided the circle into two equal halves, a minor segment, this part, and a major segment, all these parts. So the angle that was formed by the chord BC and the tangent will be equal to the angle opposite it. So always you try and see the opposite. You draw. You do something like this. You look to heaven. Look to heaven. Look to heaven. So this angle will be equal to this. Also, if it's over here, you look to heaven. Look to heaven, the opposite. So the angle over here will be equal to what? The angle over, because this chord AC has also divided the circle into what? Into segments. This minor segment and this major segment. So the angle that is formed by the tangent, by the chord and the tangent in the minor segment will be equal to the opposite angle in the major segment. In the major segment. I hope this introductory part helps, and we shall continue with the actual calculation, as this one is just a representation of the various possibilities that we may encounter. Thank you.